Capstone 2. The melting of the polar ice caps and implications for New Orleans. The unprecedented rate of global warming has had a major impact on polar ice sheets. An increase in oceanic water temperatures has resulted in the rapid melting of ice sheets at both poles. This is particularly evident with the melting of the West Antarctic ice sheets, which scientists believe is eventually going to collapse. The WAIS is grounded by a base of ice which is being constantly eroded by unusually warm waters from the continental shelf. Although the melting of the ice caps due to increased water temperatures will contribute to a rise in global sea levels, it is not the only contributor. Other reasons for global sea level rise include a slowing of the Gulf Stream, which is removing less fresh water from land surfaces, thermal expansion and land seepage due to tectonic plate movement, and the removal of groundwater. An increase in oceanic volumes will have a major impact on geographically low-lying areas, and small island nations in the Caribbean and South Pacific are very vulnerable. However, there are also areas of the contiguous United States which are likely to be submerged following a significant rise in sea levels. One of the most vulnerable of these is the area surrounding the city of New Orleans, Louisiana. New Orleans is situated on the shores of Lake Pontchartrain. This area has experienced rapid land loss due to human alteration of the landscape and subsidence. Following Hurricane Katrina in 2005, the vulnerability of the city to floods and storms was exposed. Coupled with GLSR, it can now be seen that New Orleans is one of the cities in the United States most vulnerable to climate change. Geographically, New Orleans is situated on a coastal plain in the northern Gulf of Mexico and is an amalgamation of shallow water deltas created by a shifting of the Mississippi River. The low Holocene terraces of the Pontchartrain Basin drain slowly into the lake, which in turn drains into coastal wetlands and estuaries where drainage is slow. The low elevation of New Orleans and its location on a slow-moving river delta has made it particularly vulnerable to GSLR. As sea levels rise, so do the intensity of storm surges and extreme storms, and New Orleans is located in one of the most hurricane-prevalent areas in the United States. Numerous issues contributed to the failure of levees and the flooding of New Orleans during Hurricane Katrina, but these issues will continue to be relevant during the predicted GSLR. New Orleans faces three direct future threats in relation to sea level rise: the certainty of intense, repetitive hurricane activity, reduction in the efficientness of in situ levees due to impeding sea level rise and increasing height of storm surges, an ever-increasing cost for the recovery from flooding and for building higher levees, while other cities are competing for the same dollars to solve their ever-increasing problems caused by rising sea levels. Ultimately, the solution to the problem of GSLR is to substantially and immediately take steps to reduce atmospheric carbon and other greenhouse gases. However, most governments globally do not appear to be committed to taking the step which will ultimately result in cities such as New Orleans from sinking beneath the waves.